Hello everyone, this is our final project for CS467, the capstone course of Oregon State's computer science program. For this project, we created a microcontroller home humidity sensor. Just starting with a quick introduction, my name is Trevor Carlisle and my teammates are Andrew Poon and Johanna Varnes. To make this project, we used a Raspberry Pi Pico 2W as the microcontroller. We also wrote our firmware in C. We used a DHT20 sensor to measure both temperature and humidity. We also have an H-stage LED array used to indicate humidity and temperature. And lastly, we used an LED display to show the temperature and humidity values in numerals. This project is compelling because it combines the use of software and hardware development. We are in a computer science degree, and our curriculum up until this point has been focused on software. This project gives us a real-world application into integrating hardware and software, which provides a more well-rounded educational experience. Now we'll go into some highlights, starting with the project demo and some example use cases. Here is a demo of our device. A use case for this device would be to measure temperature and humidity in your home. As you can see, the temperature and humidity is displayed on the display screen, as well as the LED array showing 4 lights indicating the humidity is between 40 to 50%. You can also see the Raspberry Pi also created a Wi-Fi network that you can visit on your mobile device to also see the temperature and humidity. Lastly, through your mobile device, there's also a button to turn the LEDs on and off, as you can see here. Now moving on to the next highlight, software architecture. There are essentially 3 buckets that are used together to produce our project. The first is the source code files. This includes the peripheral files such as display.c, ledarray.c, and sensor.c that help to run the logic for the hardware sensors and displays. Next, you have the communication module such as network.c that implements the network communication with Wi-Fi. Lastly, you have the core logic such as main.c and test_main.c that integrate the other files to all run together into a working software. After the source code is complete, the CMake build system is used to integrate the Pico SDK libraries, as well as create build files that will be used to run the software on the Raspberry Pi. Then, lastly, we have the hardware that uses the build file to run the software. For the last highlight, we have the hardware design. You can see here the 3 external hardware pieces, the DHT20 sensor, the LCD display, and the LED strip. These are all connected to the Raspberry Pi Pico using various ports on the Pico. The hardware also uses a breadboard, which is not shown here, but it helps to connect the hardware pieces together through wiring without needing to solder. Now I'll pass it to Johanna to talk about her contributions with development.
My part of the project was to develop the DHT20 sensor interface, which included obtaining, processing, storing, and returning humidity and temperature readings. To do that, of course, we had the hardware, which included the DHT20 sensor, the Raspberry Pi Pico, and various wiring components like the wires and the breadboard. We used the C programming language just because it was one that we could all use, even though we had different local environments. And the build tool that goes with C is CMake, so we used that as well. When we first got started, I was using VS Code to develop in, just because that was where the getting started examples pointed us to initially. But one of our goals was to move all of our development into GitHub code spaces so that way we would have a shared common environment that we could all work in that we knew was the same. In addition to GitHub code spaces, we also used, as you might have guessed, Git and GitHub for our version control, which was really helpful since we were using a modular development strategy, and then we also used the project management functionality in GitHub. So my steps in development started with setting up my hardware just to make sure that I knew what everything was and it was all working properly. And then after that, I started learning about the I2C communication protocol and writing the code to interface with the sensor. Following that, my next step was to resolve any issues with the sensor module, and there were a couple issues, so I'll discuss that in a moment. But after that, we were able to integrate all the different peripherals with the main.c file and start bringing it all together. And then lastly, we had a couple stretch goals, and the one that I worked on was implementing the temperature readings. So we now have both humidity and temperature. Our original plan was to read the humidity and make it available to the Pico microcontroller so that the other peripherals, including the LCD display and the LED lights, could use that data and display it. But in addition to that, our deviation was to include those stretch goals because our development went fairly well, and so we were able to include those. Some of the challenges that I faced were initially I got the I2C and the GPIO communication a little mixed up. So I ended up learning a lot about I2C, and I tried several different approaches when I was refactoring the sensor code to implement that I2C protocol. I also had some issues physically connecting my hardware. I thought it was all set up, and then it turned out that I did have my pinouts a little bit wrong. So that one took a lot of trial and error and a lot of reading online manuals, and I even consulted with AI a little bit on that one. So from this project, I learned a lot about low-level communication protocols, namely I2C, and a lot about physical wiring and pinouts and all sorts of different aspects of working with hardware, things like how to use a breadboard. And finally, I got a lot more experience with C and using collaborative tools like GitHub Codespaces.
So, building on what Johanna said, her job was to get the sensor data into the system, and my role was to get that data out to the user with the LED array, the LCD screen, and eventually through a web UI with the network module. Like she mentioned, we standardized on C, GitHub, and GitHub Codespaces. C was a language we were all comfortable with. Git and GitHub standardized our workflow, and Codespaces was a nice safety net where code compiled the same for everyone. And just like the DHT20 sensor, the LCD uses I2C protocol. I2C allows multiple devices to talk using just two wires, which help make wiring much cleaner. For the LED strip, I used PIO, programmable I/O. Unlike the sensor, LEDs need precise timing, so the PIO handles that fast signaling better. The LWIP stack, which stands for lightweight IP, it was used for the network module, and this is pretty commonly used with microcontrollers due to how lightweight and low memory it is. As far as my steps in development, they largely stayed the same with each module. I started with physically wiring up a component and then used an official Pico SDK example to test it and to give me a starting point to figure out what was going on code-wise. For example, the LED demo just runs a rainbow loop. I had to rip that out and write in my own logic, specifically the logic that maps the humidity float values to a LED scale. And finally, in my development cycle, I was integrating what I was working with the other modules in main.c. All right, original plan and deviations. The LED array and LCD display went according to plan. Nothing really was unexpected there. But we did decide to go with the stretch goal of adding wireless connectivity by switching to a Pico 2W. For challenges, the biggest challenge I faced was the constraints of working on limited hardware. For example, on the network module, I couldn't use heavy web framework, so I had to do things like write a parser to read the raw TCP strings if I wanted to do things like hardware commands. And that really leads into what I learned for this project. I learned that controlling hardware requires a slightly different mindset. It's not just logic, there's timing and physical limitations that you have to take into account.
My main contributions for development were developing the main.c and test main.c files, as well as figuring out the C make build process. The main technologies I used were the C programming language as well as the C make build process. The main steps in development involved creating the main.c framework and build process, then waiting for my teammates to complete their peripheral files, and once the peripheral files were finished, I refined main.c and then developed the test main.c file. Our original plan was to only measure and display the humidity. However, after completing that development, we had some extra time, so we wanted to also add the temperature reading and update the microcontroller to a Pico 2W so that we could also add Wi-Fi capabilities. The biggest challenge I faced was understanding the build process, as I encountered numerous errors early on. I overcame this by collaborating closely with my teammates and adopting the proven steps they used, which helped me to successfully navigate and resolve the issues. As far as what I learned, this project taught me more about writing code with C as well as basic hardware design. And now I'll show a quick demo of the test suite that I built. Alright, and here is a demo of our test file. We are going to run it by dropping it onto the Raspberry Pi Pico, and we're using a serial monitor to monitor the output here. So we're going to choose Raspberry Pi and start monitoring. This first monitor is with the sensor plugged in, so everything should be working correctly. And we will see there it starts populating and it's showing all of the test results, and then the test is complete and it runs on a loop, so it's going to run it again, and now I'm unplugging the sensor. And you should see the results for the next sensor. And so you can see here are all the results when the sensor is not plugged in. And now the test is complete. I'm going to stop just so we can go back and look. So you can see up here, it says that everything passed, the sensor was able to read correctly. And then when you scroll down to the next cycle, you can see it shows all of the failed results, indicating that the sensor did not read correctly. But yeah, that's it. Thank you. So now that we've finished our project, you might be asking where things will go from here. Unlike most projects, our humidity and temperature sensor is not a net new product. There are countless devices that currently measure temperature and humidity that are already readily available on the market for an affordable price. Because of this, we don't have any future plans to bring our product to market or develop it further. If anything, this project will just serve as experience for future projects that we want to build using the Raspberry Pi or other projects involving hardware and software integration. That's all for now, and I hope you enjoyed learning about our project.